Hi, Sam Roberts here for ProRaster Scientific. Version 2.5.01 has a new layer type called the contour layer type. So let's take a look at it, take a deep dive and see how it works. So go to the Open menu button, select New Contour Algorithm. For a raster, in this case I'll choose one that's on my recent raster list. I'm going to choose Glow 30, which is a 30 meter resolution data set for the world, and here's our contours displayed. We can zoom in and pan around and render our contours at any scale for any raster of any size in real time. So this is going to be one of my long rambling videos that I do in one take because life is too short to edit YouTube videos. And just for some background, this is the fourth time that I've written a contouring algorithm. So the first time was, back when I was a teenager. I think I wrote the first algorithm using some compiled BASIC called Power Basic, and the output was written to a file in Hewlett-Packard graphic language, and then we would copy that file across to big A0 size pen plotters, and then you'd get a cup of coffee and stand there for half an hour watching this thing slowly plot out these A0 size contour plots. And I really missed that. That was really mesmerizing. And then the next time was for Encom Technology. We wrote contouring algorithm for Profile Analyst, and that was kind of like this. This was, so it would generate contours on the fly as you're rendering your map. They were labeled, they had contour dropout, but they had, it would quickly run out of steam for large rasters or if you zoom in. And the third time was for MapInfo, and we wrote for MapInfo Professional, we wrote an contouring algorithm that was designed to output contours as vectors to spatially indexed MapInfo tables. So that wasn't for rendering immediately, it was for generating vectors. And so we produced an algorithm that could contour huge rasters and generate enormous vector files that were so large you couldn't then display them adequately well in MapInfo. So I'm not really sure what the point of doing that was, but anyway, that's still available, as is Profile Analyst. You can still go and buy Profile Analyst and use that old contouring algorithm. You can still go and buy MapInfo, of course, and use that contouring algorithm. And this is my fourth attempt at contouring, and absolutely will be my last. And this algorithm uses both your CPU and your GPU to generate contours. So, and it does it in real time. So as you're zooming around and panning, it's generating new contours and rendering them. It uses the GPU to render the lines, to render the text. And it has some nice features. So for example, the labels have an exclusion area around them so that the contour lines don't overlap the labels. It has contour dropout, so in areas where you have high density contours, the minor contour lines will drop out and won't be displayed. There's a distinction between minor and major contour lines. It can be controlled manually. You can put in your own contour levels completely manually, including all the labels and everything else. And it works at every scale. So as you zoom out, it will still contour arbitrary large rasters, and then as you zoom in, it doesn't matter how far you zoom in, your contours will remain perfectly smooth. They will never become jagged or overlap or do anything nasty. They are very high quality at all scales. And so the idea is to produce something that really helps you to visualize your data and really helps you to explore your data and make discoveries in your raster data. So let's take a look at how it works. So I used this mechanism to create a new contour algorithm, and when you use that, it puts in 2 layers into a new algorithm. So the first layer displays the raster that you're contouring, usually with a lookup table color layer. It uses this pastel color, pseudo color ramp, so it's a little bit grayed out, and so you can see your contours a little bit more easily. And then it has this new layer, which is your contour layer on top. The other way that you can add contours to your algorithm is go to the Add Layer button, and you can add a contour layer to any existing algorithm. So contours, they look like vectors. In this system, they're actually just bitmaps. But they need to be on top of your other data. So if I was to move this contour down below this imagery, for example, then it disappears. You can't see through that imagery unless you were to make it semi-transparent. So you need to put your contour layers up towards the top of your rendering algorithm so that you can see them through your other layers. So let's look at what the contour layer does. Maybe so this is terrain. Let's have a look at some magnetics. And we'll see some of the features of this contouring engine. So if I zoom into some region here, you can see some features of the contouring system. So let's go to, well actually, first let's look at the components in your contouring, in your contour layer. So on the layer level, you have standard layer controls, but you have, in addition, you have this contour levels property page and the contour labels property page. So that's where you control all of the properties of your contours. But then all of the other components that you might see in a lookup color table and whatnot are also in the contour layer. So firstly, you have the contour component. So this is where you need to select the raster that you're going to actually contour, as well as the field and the band. You can select the time range. You can apply a data conditioning filter to that raster prior to it being contoured. You have control over the color. So contours can either be some kind of fixed colors, or you can color modulate them. So let's take a look at that. So I turn off the color behind, and now we'll color modulate the contours. So go back to the levels control and say modulate color. So now my contours are in color, and I can control that color stretch. So this is just like any other color modulated layer. You need to define your data transform and your color table. So here's my color table, and you might choose something else like one of these color tables or something like that. And of course you can change your stretch, so you might use equal area stretch or whatever you want. So all those options are there for your color control, and of course you can put in clipping as well. So if we go to a linear transform and we say clip it from 0 to 1000, so there's our color stretches across that range, and then we can say invalidate above the maximum, and anything that's above 1,000 won't render anymore. So here's a contour, 1,000 level contour, and there are no additional contours above 1,000. Perhaps we should have gone for a more obvious example, let's say 500. And now our contours stop at 500. So you have all those standard controls for your colour modulation. You can also, so let's go back to a linear clip without any clipping. You can also control the opacity of your contours. So go to your opacity component, select your raster, enable it using the same raster here, and you can see that we now have different levels of opacity. Perhaps put the colour on underneath. Let's go for, say, an equal area transform. So now we're seeing contours that have high values. We're not seeing contours that have low values because because they're being opacity modulated. So opacity modulation usually operates on a per pixel level, but in this case it operates on the contour level. So whatever the contour level value is, say 500 or 1,000, that's the value that's going to be opacity modulated. So every pixel in the contour will have the same opacity. Same with colour. And then we have the mask component, which you can use to mask out the raster to some particular area. So let's do that. Let's mask it to this one. Turn that on. I'll turn off the lookup table color layer, and here we go. So contours are now limited to this small area, which is just the extent of this particular raster, which is a little terrain raster from the coast. Let's change our levels so we can see more. And there's our contours just clipped to that. Let's turn off our opacity, and my choice of colour table is a bit dodgy there, isn't it? Turn off modulate colour, so we just have black and white. So all of those options that are available in the other rendering layers are available in your contouring layers. So let's now go to the contour layer and look at the property pages for your contours. I'll go back to glow 30, and we'll zoom in somewhere, perhaps over here. I guess we're in Morocco or somewhere like that, in the Atlas Mountains. Bring up the algorithm. So we'll just turn off, or perhaps we'll just, in the lookup table color layer, we'll just take out some of the shading so it's not so overwhelming. Then we'll go to levels. So you have to specify the contour interval. This is, and by default it's set to automatic, so use the statistics and it'll come up with some kind of interval which is suitable. So you can turn that off. Now you can specify your contour spacing or your contour levels, and your major contour step. So we have minor contours at the contour spacing, and then a major contour every nth minor contour. So if I do a contour spacing of 10, and then I have major contour every 10 minor contours, that means I'm going to get a major contour every 100 and a contour every 10. Now, you can also set this anchor. So, and by default, it's always 0. And that's the sort of the value that the contour intervals are anchored to. So if I was to anchor that to 5 instead of 0, now my contours are displaced by 5. So I've still got contours every 10 metres and a major contour every 100 metres, but it begins at 5 instead of 0. So I've got major contours at 3,305, 3,205, etc. So that gives you precise control over where your contour spacing, where your contours are going to lie. You can also clip your contours from here, so you can put in, let's say I want the first contour level at 2,000 metres, and I want the last contour level at 3,000 metres. So now we're only going to be drawing contours between those levels, and here above 3,000 we're not seeing anything, and below 2,000 over here, again we're not seeing any contours. So you can clip the range of your contours. And then you've got your line styles. So you have your minor line width and your major line width. And you can see that these default to 0.75 and 1.5. So these units are in pixels, but you can use fractional pixels. So I can make that, 2 and 4. And now we have denser or thicker contour lines. And the contour lines are actually rendered as anti-alias polygons. So you can make contour lines nice and thick, and they still look very high quality when they're rendered. So, and conversely, you can make them quite thin. So if I put in a thickness of 0.5, that's below a pixel. Now when you go below a pixel, it doesn't make the line any thinner, but it starts to make the line more and more opaque. So I go down to now 0.1, and you can see the contour lines become quite opaque, and you can hardly see them. So they're not exactly getting thinner, they're just getting fainter and fainter and fainter. And just a point to note here is that if you go to the options dialog, there's an option here for pixel scaling factor. So this applies to anything that's rendered in pixel space. It usually is applied in 3D. It's also applied in contours. So if I was to make this 2, then that factor of 2 would be applied to these major and minor line widths. Or if you were to make this less than 1, again it would apply. It also applies to the font size. So this thing can be used to scale up your contour line thickness and your font size. So if you have very high resolution monitor, you might want to set that to a value greater than 1, so that everything at its standard font size and standard thickness is visible and looks appropriate. So just note to remember that that is available. So there's your line widths. Then you have your colour. So if you turn colour modulation on, then your colour is going to come from your data colour transform. Otherwise, you can set the colour for your minor contour lines and for your major contour lines. Let's make this 4 so we can see our major contour lines. So there's our nice thick ones, and we can set that to some kind of hideous brown colour. Go to custom. Where's a nice brown? There. So there's a brown contour lines. You can also set the opacity of your contour lines. So I can dial this right down, and now my major contour lines are virtually invisible. And a note here about opacity. So with all other layer types, in order to use opacity modulation or any other opacity features, you need to put the blending rule to either light table or blend. But with contours, that's not the case. contour opacity is applied regardless of what the blending rule is set to. So let's go back to our contour properties. Dial that opacity back up to 255. So there are line styles. Now let's take a look at dropout. So dropout in areas where you have high contour density, dropout will begin to remove minor contours, and maybe we'll look at something a little bit smoother. Let me get rid of that. Come back to my TMI algorithm, and turn off masking, turn that back on. Okay, so here's an anomaly, a magnetic anomaly as it turns out. So let's go into our contour properties, and I'll use a contour interval of say 2 and make this, or let's make it, I'm going to make it at 10. Hit OK. So now we have, put that over there, quite dense contours. Now, now contour dropout is turned on, so as I zoom out, at some point the minor contour lines are no longer rendered, and you can see that the region that doesn't get rendered is actually a polygonal region. If we zoom out further, more and more regions start to become dropped out. So dropout only affects your minor contour lines. Major contour lines never drop out. You can also modify when that dropout occurs. So there's a value here, and you can see a tooltip. It says from 0.5 to 5. So if I put it on 5, now I'm getting more dropout. So the dropout is happening much earlier than it was before. Here's a level of 3, and you can see these regions that are higher density contours are already dropping out. I'll go back to 1, and nothing in that anomaly is dropping out until I zoom out. And you can drop this down, and below about 0.5 it starts to not really make a lot of sense, but at 0.5 we're preventing most of that dropout. You can also see quite clearly here that if you have a label, the label has a rendering exclusion area around it, through which you will not see any contour lines. So labels completely overprint both major contour lines and minor contour lines. So that's dropout. So now let's take a look at labeling, and we'll come back to this manual contour option later. So here's our labels. So you can turn labeling on or off. So labeling's now off. Turn it on, and you can see it says label major lines. Minor contour lines are never labelled. We only ever put our labels on the major lines. You can set the font size here. So now they're a bit bigger. And you can set this label density parameter. So if I bring this down to, which is between 1 and 100, bring that down a bit, now we have less labels. Bring it up. Now we have more labels. Upward reading text, if I turn that off, you'll see that as we go around this anomaly, the contours follow, the labels follow the contours. So at this end of the anomaly, or the southern side, all the labels are upside down. If I turn on upward reading, the labels all become right side up. So in other words, they're sort of they're rendered east facing, or east in the eastern direction. And that might be a little bit easier for you to read. Your contour labels will generally be a colour, but you can also match the line colour. So if we were modulating contour colour, then we could have labels that match that line colour. But let's turn that off. Otherwise, you can set the colour, so let's set them to green, and now we have green labels. And again, you can set the opacity of labels absolutely independently of any other settings. So you can use opaque labels at any time, and you'll be able to see through those labels to the underlying layers. There's a long label option here. I'll probably come back to it. I won't come back to it. So there are two ways to render the labels. One is to rotate each individual character in the string so that the label follows the contour line, and I'll show you an example of that soon. The other way is to rotate all of the characters in the string in the same direction. So in other words, the label is on a flat rotated plane. And all of these labels are currently rendering that way. And I think that's preferable for most of these short labels. But if you have, so if I was to take this down to one character, for example, now these short labels are starting to be rotated and they'll follow the contour line. So you can see this one, for example, is rotating along and following the contour lines. The labels will be placed where there's a minimum amount of curvature in the contour line, so they tend to be pretty well behaved regardless. So this control for long labels allows you to control that threshold between rendering the label with one rotation and rendering the label with a variable rotation. Okay, so finally, I'm just going to, let's go back to our Glow DEM, and that is that one. Actually, how about we just start again and go back to standard. Get rid of that. So we'll go new contour algorithm for Glow 30. Now, so we have some contours, just standard contours. Now I'm going to zoom in here on the Himalaya, and I'm going to use manual contours. So I go to my contour levels page, click manual contours, and then load up this CSV file which has manually defined contours in it. And then I have to find them because they're tricky to find. Oh, there they are. Well, there's something. I think that's Mount Everest. I'll zoom in. And turn colour off. Just have some intensity. So here is some manually defined contours. So I've gone and I've got the height above sea level of all of the 8,000 metre plus peaks. I think there's 14 of them or something, and I've made some contours for each, a contour for each one of them. Let me just find the file, and I'll show you what it looks like. Right, so it's a CSV file, so it has a header line, and then the contour level, whether or not it's a minor contour or a major contour, the line width there, the colour, including the opacity for the line, the label itself, so you can see that we've got some fairly long labels in this one, then the label size, and then the label color, including the opacity of the label. And so that gets rendered like this, and you can see we have these long labels which are now following the contour lines. You can see that every contour line has a different color, every contour label has a different color which is different to the contour line. Some of them have different opacities, and so as you're climbing up Mount Everest, you go past Makalu, and then you go past Lhotse, and then you go past Kanchenjunga, and then you go past K2, and eventually you get to the top of Mount Everest there. So that's how you define manual labels. When you use manual contour labels, most of these controls go away. You can still turn dropout on and off, and you can still modify some things in the label settings. When you're using, and one of the things that is still active is the font size. Now, the font size that you want is specified in the manual contour file, but this font size in the settings is still important, because what it does is it generates the font at this font size, and then it scales it up and down according to the font size that you request in the manual contour layers. So if you have large manually defined font size, you probably want to define something larger here. It won't change the size of the font, but it changes the bitmap which is generated for the font. So it can change the visual appearance and quality of the label. So just keep an eye on that. And of course you can change your label density, so I can take that down and we'll get less of these labels. And your upward reading text, still available, and your long label controls. Right, so that is contouring. I hope you enjoy it. It produces very high quality contours, both geometrically and visually, very high performance. It's using your CPU, it's using your GPU. It'll work on rasters of any size, at any scale. You can zoom in. Contour lines are never going to cross, they're always going to be smooth. Of course, you can control that because that's based on your interpolation settings, and that's here, color interpolation. If I change that to nearest neighbor, then you're not going to have smooth contours. And and that is all in version 2.5.01 of ProRaster Scientific, available on the Microsoft Store. Thanks.